Welcome to Unit 4, Day 7, Part 2. In the last video, I showed you how to use 3 different formulas for factoring: sum of cubes, difference of cubes, and difference of squares. And we ended that video with 4 practice problems that look like these 4. You should have worked out the answers, and you should now compare them to my work. Notice how for each example I start by figuring out which of those 3 formulas I'm going to use. And I do that based on what I see. Is this a perfect square or a perfect cube, just like we did at the beginning of class. Please take a moment to check your work. If you find that you got 1 or 2 wrong, you should stop and go back to the first video to make sure you understand it well before moving on. Numbers 3 and 4 are a little bit more challenging, so we'll continue to work at that level. So to go one step farther, we're going to talk about incorporating what you know about a greatest common factor. You probably remember that a GCF is a term which means it could be a coefficient with variables and exponents, and it's a term that can be factored out of other terms. So for example, when I see the trinomial 10x squared plus 5x minus 20, I realize right away that each of these terms can be divided by the number 5. And 5 would be the GCF. And if I want to factor out a GCF, I'm essentially dividing each of these terms by 5 to rewrite this original trinomial as the multiplication of 5 times something else. In this case, it would be 2x squared plus x minus 4. Similarly, we can do that with variables. When I look at 12x to the 6th plus 8x to the 4th, I realize I can divide both of these terms by x to the 4th and by 4. So 12 divided by 4 would be 3, and when I take out x to the 4th, I have x squared left over. And you can confirm that if you multiply this back in, you would get an exponent of 6 following the correct exponent rule. For the second term, we would have plus 2 and no variables left there. We can also do this with x's and y's, and you just follow each piece separately. When I look at the coefficients, negative 3 and 6 can both be divided by 3. X to the 5th and x, I can take out an x from each of those terms. Y squared and y cubed, I can take out 2 y's, or y squared, from each of those terms. Left over in parentheses would be negative x to the 4th plus 2y. So with this background skill, we can go back and factor more polynomials when they aren't necessarily a perfect square right away. So looking at 8x squared minus 18y squared, first of all, I notice that these are almost squares, but not really because the coefficients don't work. So I can divide both of these terms by 2, and here's what I get. 4x squared minus 9y squared. Now, don't leave off the coefficient out front, which is the GCF. We're just going to leave it there, and we're going to go ahead and factor the inside one more time. This is now a difference of squares. I'm subtracting 2 terms, and they're both perfect squares. In fact, we're going to use that formula from the Part 1 video using A and B, where A is something that times itself equals 4x squared. In this case, 2x times 2x would equal 4x squared. And B, again, is the square root of the second part, in other words, 3y. So the full factored form, keeping the GCF out front, would be A plus B, A minus B. So 2x plus 3y, and 2x minus 3y. This is the full factored form. Let's do one more example. Down here, 24x to the 7th plus 3x to the 4th. Well, these exponents don't look like perfect squares or cubes. But let's take a GCF and see if it looks any different afterwards. First of all, 24 and 3 can both be divided by 3, so we'll take out that. And then I can also take out x to the 4th from both of these terms, which leaves me with 8x cubed plus 1. And I'm now thinking this is going to be a sum of cubes because I see that x cubed. I still want to be a little careful because I'm not really sure what to do with this 1. But let's start with a. So a is something that times itself 3 times equals 8x cubed. It looks like 2x might work. 2x times 2x times 2x, that's going to equal 8x cubed. B would be something that times itself 3 times equals 1, and actually 1 works just fine. So again, I'm not going to forget my GCF. I'll leave that out front. But then I'm going to use the formula for the sum of cubes from the last page. And that formula started with a plus b, which is going to be 2x plus 1. And then it continued with a trinomial, starting with a squared. So 2x times 2x is 4x squared, minus a times b, which is 2x times 1, in other words, 2x, plus b squared, which is 1 times 1. If you're not sure where I'm getting that formula, you need to pause and go back to the first video and make sure that you have those formulas on the first page really solidly in your mind. Otherwise, if you're ready, you should continue here with 4 more practice problems at the bottom. They look like this. Pause the video as you work these out, and then I'll show you the answers. Here are the answers. Notice how each of these examples has a GCF, and I started by taking that out. And then I had to identify which of the 3 formulas I was going to use to factor further. On the next page, you will see 3 different sets of problems. They are labeled basic, proficient, and advanced. Your assignment for the remainder of class is to complete a total of 6 problems. You could do this by doing just the basic, just the proficient, or just the advanced, or you are welcome to mix and match from these 3 levels. I would recommend making sure that the basic problems are easy for you before you move on to the proficient level. Almost everyone will need to do some of the simpler practice problems first. Please pause the video as you stop to work these out, regardless of which ones you decide to do. And when you press play again, I will show you the answers. Here are the answers for the basic practice problems. And the proficient practice problems. And the advanced practice problems.